Okay, welcome back. We are on part three of our series of lectures on terrestrial planets. This is the last one on the inner solar system. And today we are talking about Mars. Again, just a little reminder of where we are in the solar system. We are in the inner part right here. We have talked about Mercury and Venus. We'll talk a little bit about Earth at the end of today, but mostly we will talk about the red planet, Mars. Again, we are talking about the inner 3AU of the solar system. These are solid, rocky bodies with metallic cores with very similar formation mechanisms. Okay, so we'll hit Earth a little bit at the end, but right now we're going to just head straight into Mars. So Mars is a little bit smaller than Earth. It's about half of Earth's diameter, and being half the size amounts to a surface gravity of only about a third of what we have on Earth. So if we were to go to Mars, like the moon, you might feel a little bit bouncier. Mars also has the benefit of being one of the closest things to Earth, only about 34 million miles at closest approach, although it is normally much further away than that. The Martian day is also pretty similar to Earth's. It's about 24 hours and 37 minutes compared to Earth's 23 hours and 56 minutes. Since Mars is further away from the sun than Earth, it does have a longer year. So a Martian year is 687 Earth days. Um, Mars also has a tilted axis. It's tilted about 25 degrees, so it's really similar to Earth in that regard. So Mars does actually see seasons, much like Earth. We're only able to see Mars in the sky every 2 years or so because it's actually hidden behind the glare of the sun. But right now, is a time when we should be able to see the planet in the sky at night. Mars is one of only two terrestrial planets in the solar system to have at least one moon, right? Mercury and Venus. In those lectures, I mentioned no moons because there are none. Um, Earth is the only other terrestrial planet with a moon. Mars has two moons, Phobos and Deimos. These moons were named after the sons of the Greek god Ares, which is the Greek god of war. We may have known about Mars since ancient times, but these moons were not discovered until 1877. Phobos and Deimos aren't like Earth's moon. They're very, very small. Phobos is the larger moon, but it is only 17 miles across. Deimos is only 9 miles across. Both of these moons are made of kind of the same material seen in a typical asteroid. So the hypothesis is that both Phobos and Deimos are actually captured asteroids. They were captured by Mars's gravity and have been in orbit around the planet. Both Phobos and Deimos waste very little time orbiting Mars. So, Earth moons take about 27 days to orbit the Earth, about a month. Deimos, though, orbits Mars once every 30 hours, and Phobos completes 3 orbits per Martian day. Phobos is so close to the Martian surface that there um, are some locations on Mars where it can't always be seen, right? Both moons are really just zooming along. Mars has two moons right now, but it probably won't always. Phobos, the largest of Mars's moons, is actually on a collision course with the planet. Phobos is getting about 6 feet closer to Mars every century. So this means in about 50 million years, one of two things will happen. First, Phobos could simply crash into the Martian surface. The second thing that could happen is that Phobos could actually become a ring. So as Phobos gets closer and closer to Mars, the force of Mars's gravity might become too much and it could rip Phobos apart. So if that happens, the bits that used to be Phobos could keep orbiting Mars as a ring. But we will know about that in a mere 50 million years. So Mars doesn't have, it has an atmosphere, but it is much thinner. It's thicker than the atmosphere of, or the exosphere of Mercury, but it's not as thick as Earth's atmosphere. And this makes Mars vulnerable to extremes in a way that Earth is not. So one area on Mars can vary in temperature up to 100 degrees Fahrenheit over the course of a day. There's also very little, if any, liquid water. Um, there may be some. Since Mars gets extremely cold, it would be hard for fresh water to exist permanently on the surface the way it does on Earth. But if the water is salty enough, it is possible. So in the RSL, or recurring slope lineae right here, studies indicate that salty water ice under the surface is melting during the warm seasons and making kind of a sandy slush that runs down some Martian slopes to form these features. And in the cold season, it freezes again. So there's some evidence of liquid water on the surface, just not very much. We don't need to wait for the warm season, though, to make water flow. So these images right here from the Phoenix lander shows water ice not far under the Martian surface. So there are approximately 1.2 cubic miles of water ice on or near the surface of Mars, and most of it at the North and South poles. But this image kind of shows how easily water ice can be found at the more temperate latitudes. So this idea became very popular during the late 19th and early 20th centuries, that there was not only life on Mars, but a whole Martian civilization. Um, and it's based heavily on supposed observations of canals on the Martian surface. And this is also heavily based on a mistranslation. So Martian canals were first described in 1853 by an Italian astronomer priest called Angelo Secchi. He used the Italian term canale, um, which can mean canal, but it's understood he probably was referring to an alternate meaning, a gully or a channel, like something more natural. But the idea really exploded when Giovanni Schiaparelli observed and made this drawing of the canale. Canale was mistranslated into English as canals, implying that a Martian civilization with advanced engineering techniques existed. So one of the people that really took this up was Percival Lowell, famous for founding the Lowell Observatory in Flagstaff, Arizona. For 15 years, he studied Mars extensively and wrote 3 books on the subject. It's arguable that Lowell did more than anyone else to popularize this idea that Mars harbored intelligent life. In his books, he detailed what he called, quote, non-natural features on the Martian surface, which included canals and oases, which are the dark spots in between the canals. While this excited the public, astronomers were understandably skeptical. Um, they looked and they didn't see what Lowell saw. The technology existed in the early 1900s that allowed astronomers to look more closely at features that Lowell interpreted as canals. And when those observations were made, those features turned out to be simply irregular geologic features produced by natural erosion. So basically, once we got the ability to see the surface of Mars in more detail, um, it became obvious that no such canals existed on the planet. I think it's easy to kind of chuckle at these types of notions now, but I also try to put myself, in their time, right? In the late 19th and early 20th century, saw the building of the Suez and Panama canals, which were definite engineering feats of their day. Also, from what we knew about Mars at the time, it had some very Earth-like features. Mars was thought at the time to have a thick atmosphere. It has an axial tilt like the Earth. Astronomers were able to see Martian polar ice caps melt and freeze throughout the year, right? These ice caps are variable in extent throughout the year. Proponents of this idea of an advanced Martian civilization definitely jumped the gun and made wild assumptions without evidence. But the idea that we're not alone in the solar system is, understandably a tempting one. Plus, I'm not entirely convinced that we could have done better. We still see things on the Martian surface that kind of make us pause. So in the 1970s, the Viking 1 spacecraft sent back this image, which I don't know about you, but to me, kind of looks like a human face. So this structure is nearly 2 miles long. At this point, the evidence was definitive that there was no Martian civilization that would have built something like this. Um, it was likely, or it is likely just a mesa, um, just like many others in this region of Mars. It's just shadows that make it look like a human face. And that's absolutely right. You can see from this top image uh, of that, that's the same mesa, right? But this time the image was taken with a higher resolution camera called the Mars Global Surveyor. It doesn't look like a face now, right? Definitely just looks like a natural feature. So this phenomenon is called pareidolia, meaning you see meaningful patterns in nonsense, basically. Like it's what humans do. It's one of those little brain quirks that help us survive as a species. It just also makes us see human faces, or really the face of a bear right here. Um, in objects that were not designed by any sort of civilization. This image of the bear pareidolia was sent back by the Mars Reconnaissance Orbiter in 2022. The difference is that now we know better what Mars looks like, what Mars is like. The Viking missions to Mars in the 1960s and 70s proved that there was little chance of an advanced civilization living on Mars. That has not kept us from looking to Mars and wondering, though, about its potential. So, astronomer Carl Sagan once said that Mars has become a kind of mythic arena onto which we have projected our earthly hopes and fears. And he's, right. Uh, Mars crops up in our fiction all the time, whether humans are fighting them or just visiting for leisure or scientific study. Mars and Martians pop up again and again in our literature and our movies. Some of today's billionaires are really fixated on it. Mars holds us in a way that other planets in our solar system really kind of don't. We know now that there's no civilization to contact on Mars. Um, we know that to live there would require as yet developed technology. Uh, so why does Mars have this hold over us? Right, it is hard to say, but we have come a long way from the days of gleaning Martian canals from fuzzy ground-based telescopes. While we haven't yet landed a person on Mars, we've come to know our closest planetary neighbor through the use of robots and satellites. There have been more than 3 dozen successful missions to send robots to orbit and land on the red planet. So each one of these missions has given us a unique view of Mars, and I would talk about all of them if I could, but I'm trying not to spend hours and hours talking about these things. So I will stick to my personal favorite. So I do want to talk to you for a minute about the twin rovers, Spirit and Opportunity. So Spirit and Opportunity landed on Mars in 2004. So these were twin rovers designed to study Martian rocks in different areas of the planet. Among other things, these rovers were designed to study the geology of the planet and gathered data that might determine if there was ever running water on the surface of Mars. Their missions were to last 90 days, but kind of in the tradition of Mars rovers, they lasted far longer than that. Spirit became stuck in some soft sand more than 5 years after it first arrived on Mars and kept sending back data for over a year after that. Opportunity, though, continued to operate on Mars for over 15 years. The rover was only disabled by a planet encircling dust storm. The last contact with Opportunity was June 10th, 2018. So Opportunity was an incredible rover. So not only did it set the record for length of functionality, so how long it was functional on the planet, it traveled further than any rover that came before it, traveling over 45 kilometers. So this is um, kind of just a graph of how far um, other rovers had gone. The red lines indicate on like rovers that were on Mars. The gray indicates rovers on the moon. So the only one that's really come close was a USSR rover on the moon in 73, but otherwise Opportunity really takes the cake. So when Opportunity, or Oppie, as she came to be known, finally lost power in 2018, the world really mourned this little rover who was only supposed to study Mars for 9 months and instead beam back data for over 15 years. So Opportunity gets a lot of attention because of its outrageous lifespan, but both of these rovers, both Spirit and Opportunity, found some incredible things on Mars. So Spirit found evidence of water while trying to get unstuck from a sand pit. Um, so what does this image mean? What's it show? So the top inset, so right here, shows dry sand and dust that Spirit's wheels kicked up as it was traveling through the sand. The bottom inset is just normal Martian surface. In the middle, though, is a layer of silica exposed by Spirit's wheels. So right here. An analysis of the soil in this area shows that the top layer is mostly insoluble materials, things water won't dissolve. The lower layers include this silica, which is soluble. This indicates that water seeped through the soil from the top down, dissolving what it could and leaving the insoluble stuff behind in the top layer and depositing a layer of soluble material. Opportunity also found evidence of water, but this time in the form of tiny little pebbles that scientists called blueberries. These are iron-rich spherical rocks that we think get deposited like this by being carried by flowing water. So this is what was called the blueberry bowl. Spirit and Opportunity also determined that the Martian surface has a lot of basalt. It is covered in a thin layer of magnetic iron oxide dust. Basalt is something we often see after volcanic eruptions. So the hypothesis is that at least in the area Spirit and Opportunity were studying, there was Martian volcanic activity sometime in the distant past. Okay, so I promised I would not talk for hours on these planets. So I will stop with Mars there. But we did kind of gloss over Earth, and Earth is a planet too. It's a terrestrial planet that has things in common with its siblings, right? It's rocky, it has some water, more than the other ones, but the others also have, or some of the others have a little bit of water as well. And it's subject to cosmic influences like meteor strikes, right? Meteor strikes, cause mass extinction. So we are not immune from that. There's just another asteroid in the news lately that has a small chance of hitting Earth in the next 10 years. So like these are things that we have to keep an eye on. We're not immune from cosmic influences. But there's a lot that's different, right? Earth has active plate tectonics that aids in carbon capture and aids in cooling the planet. Earth has enormous amounts of liquid water, right? Way more than anything we've ever seen in the inner solar system. It has a magnetic field that protects us from some of the worst that the sun can throw at us. Our atmosphere is composed of mostly nitrogen and oxygen, and Earth is the only planet that we know of that can support basically life as we know it. So terrestrial planets all kind of started out with the same materials, though, right? The planets were formed out of what was left over after the sun was created. Why did Earth turn out so different from its siblings? So this is one of these main kind of broad motivating questions behind our study of terrestrial planets, and it keeps planetary scientists motivated, and it will keep them motivated for a long time. Okay, so this is the end of the series of lectures on terrestrial planets. Please remember to do the reading quiz and email me or come by my office hours if you have any questions.